Welcome to the course on hierarchical and multivariate data, which I'm teaching jointly with my colleague Christel Vaas-Geert Verbeke. Essentially, in this course, we will be dealing with everything that is not univariate. So we are used to ANOVA, linear regression, logistic regression, etc., where we have an outcome variable, perhaps in the presence of covariates, which we want to model, about which we want to test hypotheses, or about which certain parameters need to be estimated. This course is about everything else, where we have several outcomes that are in one way or another dependent. And because that can have various forms, we are doing this course jointly with myself, Geert Molenbergs, Christel Vaas, and Geert Verbeke. The course is then further paired with discovering associations with its entire team also, and the whole team together will therefore look in a class format through web lectures and questions and answers, but also through the activities associated through project work, look at all sorts of dependent data. The way the course is organized, where we are now, is the beginning, the introductory material, where apart from a brief biography of related references, in part 2 we will survey the land, meaning we will start from the things that we know, univariate data, and from there build a framework for all sorts of settings that are no longer independent, in other words, with dependent outcome data. Each of those will be accompanied by important key examples that will be examined further as we go. And then in chapter 3, some notation, concepts, etc. are introduced, here and there key theorems, so that we're on the same page when we move forward. Christel will then in the second part deal with a selected number of techniques of a multivariate nature. And Geert Verbeke will in part 3 look at longitudinal data and repeated measures. And what these terms mean I will come to in a moment. But for Gaussian, that means normally distributed data. And then in part 4, I will cover various settings, termed cluster data, but also a bit more general, where the outcome is of a non-Gaussian type. So, in chapter 1, we will look at a brief bibliography, a number of books that are relevant to the course and beyond. It's definitely not the idea that all these books are bought or borrowed from the library and read from cover to cover. No, it's good, one, to know where some of the material covered in the course comes from, and two, where you can find additional material. For example, some of the work on cluster data, and that's near the end of the course, but the books are in alphabetical order, especially for non-Gaussian data, especially around the NTP data example, a toxicology example with cluster data from animal experiments, that is rooted to a large extent in the book by Arts et al. The Vidyan and Giltinen, and also the book on the final page, Pinheiro and Bates, these are further reading books. Especially Davidian and Giltinen is dealing with nonlinear models. Now, we will not do that in this course, but there may come a time, of course, in practice where you say, hey, some of the things I did in correlated and multivariate data, etc., was useful, but now I need a nonlinear extension. Well, these are places to look for, of course. Diggle, Haggerty, Liang, and Ziegler is good background reading, looked at it from a different perspective on parts 3 and 4 of the course. Not about multivariate data, but yes, about anything else. And then Farmeyer and Tutz is a bit of an encyclopedic, large collection of models, techniques for non-Gaussian data that are dependent, whether from a multivariate or from a repeated measures nature or from a clustered nature. For example, if you say the Bahadur model, the book will talk about it, but not at every possible length that you could have in mind. No, it's a it's a good, quick introduction to the topic, to the modeling technique, and then it moves on to a different technique, so it's encyclopedic in that sense. It's good to realize that the book by Krzanovsky is kind of paired up with it in the sense that this is actually interested with diagonally opposite techniques. It's multivariate, whereas Farmeyer and Tutz is more repeated measures also. But Krzanovsky is dealing pretty much not only with techniques for Gaussian repeated measures. However, it's also encyclopedic in the sense that it is very complete in the techniques that exist, or at least existed when the book came out in 1988. Johnson and Wichern is the other book on multivariate methods, which is pretty much behind what we develop in part number 2 of the course, but that one is more thorough in every topic that it covers, but it covers less topics. It does cover the topics that Crystal will be covering in her part of the course, though. So Johnson and Wichern and Krzanovsky are very complementary in that sense. Fitzmaurice Davidian, Verbeke and Molenbergs is a book about longitudinal data, but it's not a gentle introduction. It is 2009, the state of the art of 2009. So the authors and a number of chapter authors they invited to write a piece. They wrote about their specialty, what was the state of the art, and what was important in the thinking at that time. And then McCullough and Nelder is a foundational book. Everything you do of a multivariate and hierarchical nature rests on univariate foundations. Now, those univariate foundations you have to have solidly in mind, otherwise you're building your extended house on quicksand. So solid foundation, what is the solid foundation? Well, in the Gaussian case, you think of linear regression, ANOVA, linear models, normal theory in general. But for the non-Gaussian framework, that is pretty much the exponential family and generalized linear models. And that's where the book of McCullough and Nelder is focused. Another extension that is kind of a natural thing to consider when you deal with repeated measures and longitudinal data is missing data. Now, that's not a topic of this course, but it will be covered in courses like Project Incomplete Data, Longitudinal Data Analysis. And yes, that's where the book of Molenbergs and Kenworth is focused. The books by Geert Verbeke and me provide Verbeke and Molenbergs the Gaussian foundation, and the Molenbergs-Verbeke book, the non-Gaussian foundation about repeated measures. So that is also behind parts 3 and 4. And with that said, we are now in a position to move into those areas, give a taxonomy, a description of the entire area, organize it so that we also know what we mean by various pieces of terminology, give key examples, and then we are well equipped to move into the later parts. But as I said, there is also a chapter 3 on notation and related topics.